If action and reaction forces are the same, guys, then explain this. I'm gonna take a dummy and place it in front of this train, and this dummy is gonna get hit by a million pounds of force. So, do you think this dummy applied the same force back on the train? Yes or no?
No.
Notice what happened. Now you're going, wait a minute. You're not convinced that the action and reaction law holds true, right? I mean, can you apply a million pounds of force back on the train? No one denies that the train can apply that amount of force on you, right? I mean, you get hit by a train, you will literally fall apart. Your torso is going to go one way, your head is going to fly in a different direction, the arms to the left, you will splatter all over the place. No one denies that. The question is, do you apply the same force back on the train? Well, Newton says yes, but then again, Newton lived about 350 years ago. Did they have trains back then? Not really. Obviously, the guy didn't see the train coming. So the question is he wrong? Did he get it wrong? Guys, this is a law. It's not a suggestion. All right, so the law is correct, which means that your understanding is not there. You're not quite understanding the Newton's third law. If the person applies the same force back on the train, a million pounds of force back on the train, which is about 50 million pounds, for a fraction of a second. It's like a millionth of a second, a thousandth of a second. What do you think is going to happen? Imagine that you're sitting on the train, drinking your coffee, texting someone, and the train hits someone. If you didn't see it happen, would you even feel it if you're on the train? You may see a head flying by, but when was the last time you saw a head flying by? If you see it, you're going to look at it, and you're going to think to yourself, look at that ball which has a face on it. I wonder where I could get one of those just before Halloween, right? You would not feel a thing. How's that even possible? If Newton is correct, what you experience is going to be 100% what should happen. The forces will be the same, right? And this force causes acceleration, right? So small mass is going to have a huge acceleration. How about the big mass? And the big mass is going to have a really, really small acceleration. Case in point. Now this mass is huge. So what happens? The acceleration of the mass is going to be unnoticeably small. All right, they're going to make this small. All right, so this is the acceleration of the train. You're going to make it very small. The acceleration of the train is going to be that small. All right, so the bigger the mass is, the smaller the acceleration is. That's almost at the dot right there. It's the same force, except bigger the mass is, the smaller the acceleration becomes. That's what it means. All right, so if the force is the same, mass times acceleration, what that means is if I keep this the same, keep this constant. So what happens as a result, bigger the mass, smaller the acceleration. All right, so which one is a larger mass? Train mass. So the acceleration of the train is going to be unnoticeably small. So going back to the person. All right, I'm just going to everyone. All right, so if you need to say something, you have to unmute yourself. All right, so person's mass is really small, which means that the acceleration of the person is going to be really large. All right, so the acceleration of the person is going to be about 1,000 Gs. That's death upon impact. And nothing much is going to happen to the train. So it does work out. Newton is correct.
Now this well-known rider was slightly the worse for wear when he had a run-in with an unusual flying object. Fabio was the honorary first.
All right, let's talk about Fabio. How do you guys know him? Does anybody know who this guy is? Fabio.
Is he a movie actor?
I don't think he was ever a movie actor, but he's famous because of...
He was on romance books?
Oh, he was on the cover of old romance books, right?
Oh, yeah.
I mean, your mom probably had those romance books. Okay, so he was on the cover. He was a model from Italy, and he was also on I can't believe it's not butter commercials. Do you guys remember that? When you were like 1 or 2?
Right.
All right, so Fabio, his face is his resume. This guy's famous.
They're opening up a new amusement park attraction in Virginia. Unfortunately, his ride was soon over when during his first 73-mile-an-hour plunge, he collided with a bird.
Okay, so this is a head-on collision. In this case, it's a face-on collision.
Fortunately,
See that broken nose?
his famous face.
All right, so given the fact that the action and reaction forces are the same, given the fact that he has a broken nose, what do you think happened to the bird? His face is real massive. Bird is not so much. So what do you think happened to the bird?
He probably
Died?
Dead upon impact. All right, smaller mass suffers a larger acceleration. Dead upon impact.
Was soon restored to its former glory.
So what do we know about Fabio? His face is his resume, guys. He's also the first and the only human being who was able to kill a bird with his face. Stuff that this guy could do with his face is amazing. Oh, space aliens. How many of you guys believe that we're being visited by space aliens? Oh, this is neat. How did that happen? I can see my Right. How many of you guys believe that the space aliens are real?
I guess I do too.
Okay, you know, what I'm looking for a justification for that kind of reasoning.
Well, the universe is so big, you can't just expect that we're the only intelligent life form out there. I mean, even if they're billions of light years away, I mean, there's something else out there. We may not be able to get to it, but I mean, it's sort of narcissistic to think that we are the only intelligent life form in the universe.
Okay, Rachel, is that you?
Yes.
Okay, I'm gonna give you 10 points. That was an elegant argument that you made. Do we even know how life formed here on Earth? Guys, this course is astronomy, more like astrophysics, because I'm a physicist. The question of life, where does life come from? The universe, as far as we're concerned, Big Bang, so energy turns into matter, and then you have these particles called atoms. They form molecules. From molecules you get cells. From cells you become you, I become me, and we have this discussion, right? So this all could be traced back to the beginning of the universe. But when you go from chemistry of these molecules into the biology of a living thing, the cellular structure, something happens, which is known as life, the consciousness kicks in. So the question is, where does the consciousness come from? All right, so this is one of those things that we will look into. Where does life come from? All right, so if life happens here by chance, and we don't quite exactly know exactly how this happened, it can happen elsewhere in the universe. All right, so no one questions that. The biggest problem that us, the physicists, had wasn't so much that we're special and this is the only place where life exists. The question is, the universe is just so incredibly big. Can you even travel in the universe from one place to the next place? Case in point, 3-4 years ago, we discovered an Earth-like planet. We called it the Super Earth. It was located 800 light years away from the planet. 800 light years, which means that at the light speed, it would take us 800 years to get there. All right, so basic understanding is, if we cannot get there, they cannot get here either. Even if there are creatures living there who are maybe just as intelligent as we, if we cannot do it, it cannot be done. Okay, so that was an understanding that we had. So what's wrong with that statement that I just made? Really thought about this sort of stuff.
The very idea of alien life on alien worlds was once incendiary. In the year 1600, at the Field of Flowers in Rome, a pyre was prepared for a heretic. His name was Giordano Bruno, a philosopher and former monk. Bruno lived only a few years before telescopes were invented. Yet Bruno was convinced that every star had planets, and every planet teemed with life. Didier Queloz was risking his career if he had been incorrect, but Bruno, whether right or wrong, had risked his very life. Imprisoned for 8 years by the Inquisition, he had been begged to recant. On this day, there would be no such offer. Other worlds, a disturbing idea, an idea that must be suppressed. Wasn't Earth a unique creation? Would each of Bruno's worlds have its own Jesus? Pull on one thread of Bruno's thinking, and all of Catholicism seemed to unravel. His writings were declared erroneous, his volumes ordered burned and placed on the index of forbidden books. But Bruno remained defiant. Most criminals were strangled first and later burned in effigy, but Bruno's heresies were so corrosive that he was sentenced to die by flame. The man who dared to say that Earth was not the only world God created now paid the terrible price of his convictions.
So about 400 years ago, you would have been burnt alive for holding the belief that there may be living things out there.
From the Discovery Channel and ABC News, Discovery Newsbreak.
We live in a galaxy that holds roughly about a billion stars, and there are billions upon billions of galaxies out there. So if we're the only life forms within this galaxy, there's a 1 in a billion chance that there's going to be intelligent life in other galaxies as well. So which means that the universe might be teeming with life as we speak, except that life happens in Earth-like planets. So are there any Earth-like planets? So the question, of course, the answer is yes. So the question is, how do we find them? All right, so this clip is really, really old.
Good evening, everyone. Astronomers announced today they have found 6 new planets orbiting nearby stars. This brings the total number of planets discovered beyond our solar system to 28.
Now we got thousands.
Astronomers find planets by looking for stars that wobble. That unsteadiness is caused by the faint gravity of an orbiting planet pulling on the star. That's Discovery Newsbreak.
Technology has moved on, but originally, how were we actually finding these planets? All right, here's the way we used to do it. Now, gravity extends all the way out to the moon, so the action force is acting on the moon. The reaction force is going to act on the Earth. Now, action and reaction forces being equal means this. Moon is not as massive as. All right, so the force of gravity acting on the moon, instead of going in a straight line, is going to start to orbit the Earth. Now, the same force is acting on the Earth, which means that the Earth, because it's much more massive, it's going to end up doing a smaller counter orbit. Now imagine that this is the sun. Obviously, this is the planet if that's the case. Or imagine that this is the star and this is the planet that belongs to the star. We can see the stars just fine, but we cannot see the planets directly. Stars are the sources of light. Planets just reflect light. And the reflected light is so dim that you're not going to be able to see it directly. So what is it that we see? We can see this counter orbit of the star. All right, imagine that this is the star that we're looking at. If there's a planet going by, you're not going to be able to see the planet. But here's what the star does. It does a small counter orbit. You can see the motion of the star because the color of the light is going to shift from the blue end to the red end and from the red end to the blue end, depending upon what the star is doing. When the star is moving towards your telescope, there's going to be a shift in color towards the red end, towards the blue end. When it's moving away from the telescope, there's going to be a shift in color towards the red end. All right, so this is known as the relativity.
When she sees the speed of a star change with a clear rhythm, she'll know the star has an orbiting planet. Just as two rollerbladers spin around each other, a planet and its star are in mutual orbit. Gravity works in both directions, so that even a small object like a planet will cause a much larger object like a star to wobble. Such a wobble in a distant star would be indirect evidence of a planet. But how do you see the wobble of a star? Just as sound rises in pitch as its source travels toward us, and drops as it moves away, so light shifts in color as a star wobbles. For years, Fisher and her collaborators have been looking at a star called Gliese 876. The star's color has been shifting. Fisher is hopeful she's seeing a wobble caused by it. Fisher isn't the only researcher to look for rhythmic star motion. In 1994, another team was searching the constellation Pegasus. Back then, no one had ever found a planet around a distant shining star. Astronomer Didier Queloz thought he saw a star wobbling because of a planet. If Queloz was wrong, his credibility and his young career might be destroyed.
I realized that it was highly risky if the data turned out to be wrong and a mistake. It would have been very bad for me.
The technical challenges were reason enough for caution. Earth zooms through space, but stars move slowly.
It's as if you were in a rocket and trying to monitor the speed of ants on the ground.
Queloz had to figure out what his measurements meant. He first convinced himself he wasn't seeing sunspots on his star, called 51 Peg, rather than star motion. He next made sure the star wasn't quivering like a serving of cosmic jello, rather than moving back and forth. Finally, Queloz knew what 51 Peg wasn't. Now he had to take the leap to say what it was. Didier Queloz's star was wobbling. After careful study, only one explanation made sense. An unseen planet must be moving 51 Peg. Queloz had discovered the first planet orbiting a distant shining star. But others were skeptical.
When we announced 51 Peg, I think that maybe only 10% of people believe we had a planet.
Scientists never thought such a world could exist. It was a planet 140 times the mass of Earth, and it wasn't supposed to orbit this close to its star, according to planetary theory. Queloz's world is an unlikely sight for life. It whips around 51 Peg every 4 days. The temperature is 1,500 degrees Fahrenheit, so hot that the metal nickel vaporizes, perhaps adding a blue glow to the fiery atmosphere. After Didier Queloz's discovery, other planet hunters knew they were on the right track. Now more than ever, Deborah Fisher and co-workers were eager to find their own world. If her star is really wobbling because of a planet, she should be able to predict the star's next move. Fisher began with the star speeds she had measured. She then used these measurements to make predictions of what her star would do next. As she observed her star again on a series of nights, each of her predictions came true. Deborah Fisher had found her first planet.
But it's a very powerful feeling to make a prediction and have the star obey my command.
Fisher's planet is a ball of gas nearly 700 times the mass of Earth. Her planet swings in a wild orbit that takes it from burning proximity to the star to a freezing distance.
All right, so
as the light leaves the star and the star wobbles, the spectrum of light from blue through red shifts back and forth in space, and that Doppler shift of the light back and forth tells us that in fact there's a planet yanking on the star.
As the star wobbles towards the telescope, its light goes blue. As it wobbles away, red.
And that amount of Doppler shift allows us to determine the mass of the planet and the orbit of the planet.
all right, so in order to figure out whether or not some of these stars are planets,